All right. Well, tomorrow's the test. I hope you're feeling okay about that. And we have a perpendicular bisector right here on number one. How do I know? Well, it's coming down here at a right angle, perpendicular. That's the same thing, makes a right angle, perpendicular. And then you can see this segment here is equal to that one. That means that this point right here is the midpoint, right? So this is the midpoint right there. So let's see here. What do we know about a perpendicular bisector? Well, any point on the perpendicular bisector is going to be equidistant from the two endpoints. So here's an endpoint over here. Here's an endpoint over here. That means that D being on the perpendicular bisector is equidistant from those two endpoints. So all I have to do is set up an equation that sets these two expressions equal to each other. So here we go. I've set the expression for the length over here equal to the expression for the length over there. And I just start doing my algebra. Let's see. I think I'm going to move all the variables to the right side and the constants to the left side. There's lots of different ways. You don't have to do it this way. Let's see. Could I do subtract 2 from both sides? So I get the constants on the left side, and I get the variables on the right side of the equation. And now all I have to do is divide by 3. So divide by 3, and I end up with A equals 3. You got to be careful. What are they looking for? What's the length of DE? So DE is equal to 10A plus 2, but now we know A is 3, so I'm going to go 10 times 3 plus 2. That's 32, right? So 32 is my answer for number one. All right, number 2 says that we have a circumcenter, and we said that the circumcenter is equidistant from all 3 of the vertices. So what does that mean? That means that this piece here is equal to this piece here is equal to this piece here. It doesn't mean that this distance here, 7.2, is the same as that one, is the same as that one. That would have to be the incenter if that was going on. But this is the circumcenter. So how does that help me out? Well, if this is 13.1, this is 13.1 over here. We also have a perpendicular bisector. So that means this piece is equal to that piece. So if I can find out how big x is, this one over here is x also. And that means I just double it to get AE, because that's what they're looking for. They're looking for how big is AE. So I go something like this. I go 7.2 squared plus x squared is equal to 13.1 squared. And then I subtract 7.2 squared from both sides, 7.2 squared. Now the problem with this is I've kind of lined it up so that you might feel like, okay, well, I could just subtract these 2 right here, but you've got to do the exponents before you do the subtraction because of the order of operation. Please excuse my dear Aunt Sally. See, addition and subtraction are down at the bottom, meaning it's the last thing we're going to do. We've got to deal with the exponents before we do subtraction, right? So one way to do this, 13.1 squared minus 7.2 squared, is to jump over to a program like Desmos. Let me open up a little screen here and just type in Desmos. I go there so often, I just hit VES, and it says, you want to go to Desmos, don't you? Yes, I do. And I type in here 13, what was it again? It was 13.1 squared minus 7.2 squared. This is the way I would do it. 13.1, and then I hit shift 6. That puts me up in the exponent. So I go 13.1 squared, and then I want 7.2 squared subtracted from it, 7.2 squared. So that's 119.77. Now, probably the safest thing to do is, I'm going to take that and I'm going to copy it down to the next line, and I'm going to put the square root over it, SQRT, and I get 10.94. Now I could take 119.77 because it looks like it stops in the hundreds place. See, I don't want to round my answer until I'm completely done with all my work. You might ask, hey, where'd that square root come from? Well, remember we had this squared, we have x squared. So to undo a squared, we got to take the square root of both sides. And we're going to take the square root of that 119.77 number. So I go 119.77, right? And so my X is approximately, let's see, 10.944. I'm going to put 10.944, 10.944. Well, why did I go out to the thousandths place? I guess I didn't need to go that far because they want us to round to the tenths place. So I have to just look, let's see, here's the tenths place. So I look to my right and I say, okay, that number is below half. If it was a 5, then I would keep looking to the right to see, is it above, halfway, or is it less than halfway to 0.9? Well, right now we're less than halfway. It would have to be 51 if I wanted to be a little bit more than halfway, right? To 9. So since it's less than halfway, I'm going to round down. So I get 10.9, 10.9. All right. Are there any units? I probably should add. No, there's no units to this. All right. That's how we do number 2. Number 3. All right. So what's the deal with an angle bisector? How do I know I have an angle bisector? Well, they've got this marked as this down here is equal to each other. So that means we got an angle bisector. So this is 21 degrees here. And any point on the angle bisector is equal distant from the sides. So it's almost like number 1. We had perpendicular bisector that's equal distant to the endpoints. This one's equal distant to the sides. So I'm going to go 4x plus 6 is equal to 7x minus 12. And then we just, subtract 4x from both sides, and we add 12 to both sides. And let's see, what do we end up with? We end up with 18 on this side, and on the other side, we end up with 3x. If I divide both sides by 3, that's going to undo this 3 times right here for the x. Now I got 1x instead of 3 x's, and I got x equals 6. I take the 6 and I put it back in. Let's see, what do they want me to find? Q. Oh, wait, I'm on the wrong one here. Find the length of CB. CB is right here. So if I put 6 in here, let's see, that would be 4 times 6 plus 6. That's 24 plus 6 is 30. So I've got 30 for this answer. And on the test, there's going to be like a blank here, like a box. And you just put 30 right in that box. Now it says, how big is BDA? BDA. The D is the vertex. So we go from B to D to A. So they're talking about this angle right here. We already said that's 21 degrees. So hopefully I'm making that clear on number 3. Number 4, let's look at number 4, and then we'll stop the video and we'll set up a different video for the other one so people don't have to scroll through as much. MQ is what they're looking for. Well, where is MQ? MQ is this piece right here. And we know if they have a centroid, this piece over here is half as much as this piece over here. So the short piece of the centroid is half as much as the long piece, or the long piece is twice as much as the short piece. So if I call this part x, then this part over here is going to be 2x. And if I take x plus 2x, that's got to be equal to the whole length because of segment addition postulate. And I get 3x equals 51. Now I divide both sides by 3, and I get x equals 17. Okay, so my x is 17, so I just got to make sure I put the 17 in the right blank. So MQ is 17. And then QL would be twice 17, or it'd be 34. All right, so I hope that made sense for 1 through 4. Thanks for watching the video.